So this surface plasmon resonance condition in a gold nanoparticles, which is strongly absorber of visible lights, and due to this achieved the resonance conditions. So he surface plasmon resonance condition 50 नॅनोमीटर्सच्या ज्या नियर अबाउट असेल तर ती विजिबल रेंज मध्ये होते. And this is achieve these conditions in a visible range of your nanoparticles, that is a gold nanoparticles, right? So this gold nanoparticles achieve these conditions, that is a surface plasmon resonance conditions. SPR. आता हे surface plasmon conditions कुठून आली तर हे आपल्याला बघाय इथून आलंय. So if you consider this equation, basic equation I is equals to I0 into e raised to power minus mu into x. So mu is the n upon v c extensions, right? So this c extensions, it is means the extension cross section of the particles. N is the number of particles of the medium and v is the volume of colloidal particles. So according to this me theory, this C extensions is given as C extension equals to C absorptions plus C scattered. So this me theory means C extension, it means that the 24 pi square I raised to power 3 epsilon that is the dielectric constant of a medium, it is 3 by 2 upon wavelength into this. This is one imaginary part, and this is epsilon 1 is the real part of those complex dielectric functions, and that will be the into dielectric constant of medium. And this one is the figure, and this is the total imaginary and real dielectric constant of a medium. So if it is considered as a epsilon equals to E1 plus I into E2, so that is the constituent material of the nanoparticles. But epsilon, that medium dielectric constant of a real number, and if it is real number, then this here having 1 and epsilon equals to 1, but the blood is 1.4. So it means that it is different for this, the medium is different, or it is the nanoparticles or material is different. So याचाच अर्थ असा आहे की हे जे इक्वेशन्स आहे, it is implies that the maximum extension is possible, that is 0 is equals to epsilon 1 plus 2 into epsilon m. So it depends only on the materials and not in the size. But so the wavelength of a strong surface plasmon resonance, आता surface plasmon resonance मध्ये it does not change with the particle size, but for the particles are radius greater than 0.1 wavelength एवढी जर असेल तर it is near about the 50 nanometer and it shows the visible regions. So that time this equations it is failed, and if it is failed, it does not depends upon the material, but it is depends upon the SPR is size dependent when R is greater than 0.1 lambda असं असेल तर. So if it is considered as this one, the surface plasmon resonance means it is a light which is having the electrical field and it is incident on the colloids or the on the electron clouds. So that nanoparticles, that time it is oscillated, and this oscillation conditions of your the electrons cloud, that condition it is called as the surface plasmon resonance. म्हणजे तुमच्या लक्षात येत असेल की जर कुठलंही मटेरियल घेतलंय, फॉर एक्झाम्पल एखादं मटेरियल असेल तर त्याला काहीतरी सरफेस असणार आहे. त्या सरफेस म्हणजेच काय, तर हे नॅनो पार्टिकल आहे, याला हा सरफेस आहे. इथे जे काही इलेक्ट्रॉन्स प्रेझेंट असेल, आतमध्ये जे काही इलेक्ट्रॉन्स प्रेझेंट, हा इलेक्ट्रॉन क्लाउड आहे. जेव्हा लाईट याच्यावरती पडतोय तर लाईट सोबत काय इलेक्ट्रिक फील्ड आहे. सो ड्यू टू दिस इलेक्ट्रिक फील्ड, if it incident on this electron cloud and it will be oscillates, हे oscillates व्हायला होतात. So that condition, this conditions it is called as the SPR, that condition it is called as the SPR. So these conditions if you study with the gold nanoparticles, it is a very strong absorber of the visible light, that is the near about 50 nanometers. So that absorption condition it is achieved in the this SPR condition achieved in the gold nanoparticles, right? So this is all these are the conditions of the nanoparticles or these resonance conditions, which is only the size dependent, or it is not a dependent on the particles, that is the particles which is the materials, त्या मटेरियलच्या वरती ते डिपेंडंट नसते, तर ती कशावर डिपेंडंट असते, साईज डिपेंडंट असते, इन द फॉर्म ऑफ द एसपीआर, इन द फॉर्म ऑफ द एसपीआर. म्हणजेच ते मायचे जे इक्वेशन्स आहे, that equations it is fails. So that absorptions and scattering, the beam of light excite the loosely bound surface electrons to form a surface plasmon resonance, and which itself can generate heat, in which the remote light has gone into the absorptions, and it also acts as a dipole shaking at the frequency of a light, and itself becomes the source of light. So in this case, we can remove the light is converted into the scattered one, and both the process of are useful in the medicines, and the scattered light or becomes is visible. So this optical microscope, due to which the positions can be determined. So this generated by absorptions can be used for the further treatment, and that is called as the hypothermia. ह्या सगळ्या मेडिकल फील्ड मधल्या टर्मिनॉलॉजीज आहे ज्या आपण एसपीआर मध्ये युज करू शकतो. म्हणजे एसपीआर मध्ये ऍब्सॉर्प्शन्स अँड कॅटरिंग हे दोन जे आहे, आफ्टर द इन्सिडेंट ऑफ युअर लाईट ऑन द मटेरियल्स, दॅट टाइम्स surface plasmon resonance conditions will be achieved, and that achieved conditions we can use to determine the different types of cancers and different types of as and the treatment called as the hypothermia, त्याला आपण hypothermia असं म्हणतोय. So that extensions by the particles depends not only on the optical properties of the material, so but on the optical properties of the medium in which it is the distribute as per the that equations. ते जे equations आपण बघितलेलं आहे त्या equations नुसार, तर ते equations कुठलं आपण बघितले, that equations, that is the equations, the C extensions 24 pi square I cube epsilon m 3 by 2 pi upon lambda is equals to E2 upon E1 plus 2 into Em raised to power 2 plus epsilon 2 square. So this is the equations which is given as the extension efficiency, that Q extensions, and that will be the C extension, and which is denoted by, or it is simply divided with the cross sections of the particles. So that is the Q extension is equals to C extension upon pi r square. आणि त्याच्यावरून आपण सी एक्सटेन्शनची जर व्हॅल्यू तिथे पुट केली तर दॅट इज द इक्वेशन्स कम्स. हे जे इक्वेशन्स आहेत ते इक्वेशन्स कसं होईल, तर इट इज सिम्पली द इक्वेशन्स लाईक दिस Q extension, this Q extensions is equals to C extensions upon, it is a pi r square, it is a pi r square. आता आपल्याला ही व्हॅल्यू माहित आहे, ही व्हॅल्यू इथं पुट केली इक्वेशन्स मध्ये, तर काय आहे 24 पाय स्क्वेअर इंटू आर क्यूब इप्सिलॉन एम रेस टू पॉवर 3/2 अपॉन, आता इथे ऑलरेडी लॅम्बडा आहे, सो लॅम्बडा इंटू पाय आर स्क्वेअर इंटू this epsilon 2 upon epsilon 1 plus 2 into epsilon m raised to power 2 into this is epsilon 2 square. So here r square and r cube, r square get cancelled. Here lambda square and lambdas cancel. So the equation becomes, equation कसं होईल तर Q extension coefficient, that is the extension of light, that is 24 pi, it is r into epsilon m raised to power 3/2 upon this lambda, इथे फक्त lambda राहिलाय, into epsilon 2 upon epsilon 1 plus 2 into epsilon m raised to power 2 into epsilon 2 square, So this is the extension coefficient of lights, it will comes, this is the extension efficiency, and which is depends upon the r and dielectric constant of the medium, म्हणजे तो r वर आणि dielectric constant of medium वरती dependent आहे. So this relative amount of extension and absorption depends upon the particle size, and in a small particles, आता पार्टिकल साइज वर डिपेंडंट आहे असं जर आपण म्हटलं एसपीआर मध्ये, तर it is small particles, that is 20 nanometers, and extension is almost entirely due to the absorptions. जर असं आपण कन्सिडर करतोय की जर नॅनो पार्टिकलची साईज नियर अबाउट 20 नॅनोमीटर असेल, तर तुमच्या असं लक्षात येईल की इथे एसपीआर हा जो तयार होतोय, this SPR, it is totally depends upon the absorption process. This totally depends upon the absorption process. And if this large particles, that is the 80 nanometers, जर 80 nanometers एवढं जर तुमची साईज येत असेल, तर that is totally depends upon the absorptions as well as the scattering of light. So both इक्वली त्या दोघांवरती, म्हणजे ऍब्सॉर्प्शन प्रोसेस आणि स्कॅटरिंग प्रोसेस, जेव्हा तुमचा लाईट त्यावरती पडत असेल तेव्हा ऍब्सॉर्प्शन, स्कॅटरिंग आणि ट्रान्समिशन होते. सो आउट ऑफ दिस ऍब्सॉर्प्शन अँड द स्कॅटरिंग इज व्हेरी इम्पॉर्टंट. If the nanoparticle size is comes to the 20 nanometers, near about the 20 nanometers, then that entire process is totally depends upon the absorption process. But the nanoparticle size is comes to the 80 nanometers, that time your this entire process of interactions, it is totally depends upon the equally on the scatter and the absorption process. अशा पद्धतीने तुम्ही तिला डिस्टिंग्विश करू शकता, बिकॉज that time it achieved the SPR or the surface plasmon resonance. हे केव्हा absorption and scattering, it is two processes, and your nanoparticle size is dependent on that absorption and scattering process. So the beam of light is excite the loosely bound, जेव्हा लाईट जी काही बीम असेल ती लूजली बाउंड असेल surface electrons to the form surface plasmon resonance, and which itself can generate the heat. तेव्हाच तो हीट जनरेट करतो, तो इलेक्ट्रॉन जर लूजली बाउंड असेल तर, म्हणजेच तो हीट काय होईल, हीट निघून जाईल. सो दॅट टाइम युअर the size dependent or the size process, SPR process, is totally depends upon this absorptions. So heat in which the remove from the light has gone into the absorptions, and it also act as a dipole shaking at the frequency of light and itself becomes the source of light. So that in this case, the removed light is converted into the scattered light, and both the process are useful in the this determinations of the nanoparticles and their sizes. त्याची साईज आपल्याला वेगवेगळ्या पद्धतीने डिटरमाइन करता येतात, and that the process are you are using in a medicine to determine the positions of the different kinds of the materials, and that heat generated absorptions can be used for the treatment of the cancer, that is called as the hypothermia. So this is applications of your this characterizations techniques, and which is based on of this achieved the condition, that is the SPR conditions, and which SPR condition is depends on the size of the nanoparticles. The size of the nanoparticles वरती डिपेंड असते, म्हणजे कुठली प्रोसेस तिथे यूज होते ते आपल्याला सांगता येते. So that relative proportions of the scattered and absorbed light, it varies the functions of the particle size. So it means that the frequency of a surface plasmon resonance, this oscillations is given by the equation of loosely bound electron oscillations. म्हणजे हे जे इलेक्ट्रॉन क्लाउड्स असतात, आता इथे जे इलेक्ट्रॉन्स क्लाउड्स आपण म्हटलेले आहेत, that electrons clouds, just see the figure, this one, this electron clouds. आता हे जे आहे इलेक्ट्रॉन क्लाउड आहे, आणि रेड कलरने मी जे काही दाखवलेलं आहे, दॅट इज द रेड कलर, दिस इज अ हॅलो एरिया, इट इज द हॅलो एरिया, बिकॉज ही स्पेस आहे, ही फ्री स्पेस आहे, and that electrons clouds so loosely bound this electrons, and it is goes into this heat or this absorption process. So that the equations of SPR, this SPR, the surface plasmon resonance, can be used. The equation WP is equals to the root of 4 pi n e raised to power 2 upon m star. So where n is the number of electrons in plasma, then is the charge on the electrons, then the m star is the effective mass of electrons, This is observed that the wavelength of frequency of the resonance of pure gold nanoparticles, which is spherical in shape, so that time it's visible in the remains in the visible region. So we know that this wavelength decide the wavelength of scattered and the absorbed light, and which is the depends on the size of the nanoparticles, and which is not depends upon the materials. So this is that the wavelength of the scattered and absorbed light, it is decide the color of the solution. हे आपल्याला माहित आहे की the size of the nanoparticles हे decide करते की तुमच्या सोल्युशनचा कलर कसा आहे. So which is mainly depends upon the size of the nanoparticles of the gold nanoparticles or any metal nanoparticles. If the different colors of the nanoparticles of a metals, it means that their sizes are so different. Their sizes are so different. So this is the characterization technique of a metal nanoparticles, that is a surface plasmon resonance, which is given the final conclusions of a metal nanoparticles final conclusion सुद्धा हेच आहे की if the size of color is different of nanoparticles, metal nanoparticles जर color different असेल तर याचाच अर्थ असा आहे की त्याच्या size सुद्धा different आहे. So 10 nanometers, 30 nanometers, 20 nanometers, if there's different sizes of the nanoparticles, there is the most probability that their colorations it is also different. ते सुद्धा different असतात. So this is all about the metallic nanoparticles. हे सगळं metallic nanoparticles आणि त्याचं characterization technique आहे, that is surface plasmon resonance. This is the one of the conditions which is achieved by the metallic nanoparticles, and this conditions it used to determine the different kinds of the nanomaterials. हे सगळं आपण करू शकतोय, आणि त्याचं याचं सुद्धा फायनल स्टेटमेंट असं आहे, जसं तुमचं ऑप्टिकल प्रॉपर्टीज ऑफ द सेमी कंडक्टिंग नॅनो मटेरियलचं आहे, तसंच याचं आहे की इट इज साइज डिफरंट देन द मटेरियल्स ऑफ द नॅनो पार्टिकल्स ऑर द नॅनो पार्टिकल्स, देअर कलरेशन्स ऑल्सो डिफरंट. So this is all about the optical properties of the nanoparticles or nanomaterial, that is semiconducting nanomaterials as well and the metallic nanomaterials or nanoparticles. Okay, rest of the things, that is the characterization and fabrication, that is the characterization techniques we see in the next lectures. So that is the characterization techniques we are using to know the size, structure, type, atoms, all these things we can discuss in the next lectures. Okay, so now I am going to stop the class. आता इथे मी थांबतोय. Okay.